So in our today's lecture, we will talk about factorization by breaking up the middle term. Now, in order to understand this topic, we need to make sure that you have an equation in the form ax squared plus bx plus c, just like given over here in the example. Ax squared plus bx plus c. Now over here we have 5x, x squared plus 5x plus 6. Now we have to break 5 in two numbers, such numbers that we multiply them so that we get 6. Now the two numbers over here are 2 multiplied by 3 would give you 6 and 2 plus 3 would give you 5. If both of your conditions are met, only then you can factorize by breaking up the middle term. So you will write x squared plus 2x plus 3x plus 6. Now instead of writing 5x, I am writing 2x plus 3x, which is the same thing. Now we will take x as common and we will get x plus 2, and over here we will take 3 as common and we will get x plus 2. Note the fact that both of these brackets are same. If both of these brackets are same, then your initial answers would be correct. Now we will take x plus 2 in common and we would be left with x plus 3, and hence this is your answer since you have factorized. Moving on to part 2, we have x squared plus 10x plus 24. Now note, we need two numbers such that when we add them we get 10 and we multiply them we get 24. Now such two numbers can be 6 and 4, because 6 plus 4 will give us 10 and 6 multiplied by 4 will give us 24. Now instead of writing 10x, I will be writing x squared plus 4x plus 6x plus 24. In the first term, there are two terms. In the first term, we will take x as a common and we will get x plus 4 plus, and in the second term, we will take 6 as the common. Therefore, we will get x plus 4. Once again, note how both of these terms are same. Since they are same, we can assume that our answer will be correct. Now we will take x plus 4 as the common and we will get x plus 6 as the remainder, and hence you have simplified and this is your answer. If the question asks you to find the value of x, then you will say x is equals to minus 4 and x is equals to minus 6. Moving on to the third question that we have over here. In this question we have x squared plus 12x plus 27. Now note, we need two numbers such that when we add them up we get 12x and when we multiply them we get 27. Now such two numbers can be 3 and 9, because 3 plus 9 is equals to 12. You have met the first condition, and 3 multiplied by 9 is equals to 27. Therefore instead of writing 12x, you would be writing x squared plus 3x plus 9x plus 27. Now in the first term you will take x as common and you will get x plus 3, and in the second term you will take 9 as common, you will once again get x plus 3. Since x plus 3 is a common, the remainder would be x plus 9, and hence you have solved your question. Moving on to question 4. Over here we have x squared plus 19x plus 60. Now sometimes it gets very difficult for you to get the two numbers. Therefore, in order to make things easier for yourself, you will make this t table and write 60 over here. Now you will write the numbers which you multiply, you get 60. And since the numbers can be 1 multiplied by 60 itself, 2 multiplied by 60, and the list goes on. And eventually you will get the numbers 15 and 4, because 15 4 is also 60. Now note, 15 plus 4 is equals to 19. None of the other numbers is equals to 19. Only 15 plus 4 is equals to 19. Hence, we know that our two numbers would be x squared plus 15x and plus 4x plus 60. Hence, instead of writing 19x, you would be writing 15x and 4x. In the first one, take x as common and you will be left with x plus 15. And in the second one, take 4 as common and you will be left with x plus 15. Since you're left with x plus 15 is your remainder, you will be writing x plus 15 as a common and x plus 4 as the remainder, and this you have solved your question. Moving on to question 5. Over here we have x squared plus 13x plus 40. Now we can make a t table for 40. We know that 40 ones are is 40, 2 20s are is 40, and so the list goes on, and then we will get 8 5s are 40. Now note, 1, if we add or subtract 1 with 40, we won't get 13. If we add or subtract 2 with 20, we won't get 13. But if we add 8 plus 5, we would get 13. Hence your first requirement is met, and 8 multiplied by 5 is also equal to 40, and your second requirement is also met. Therefore you can break this term by writing x squared plus 8x plus 5x plus 40. Instead of writing 13x, you can write 8x plus 5x. You can take x as common, x plus 8, and you can take plus 5 as common, then you will be left with x plus 8. Since x plus 8 is your common, you will write x plus 8, and the remaining numbers are x plus 5, and hence you have solved your question. Moving on to part 6, your question is x squared minus 10x plus 24. Now we need two numbers such that when we add or subtract them, we get minus 10x, and when we multiply them, we get plus 24. Now these two numbers can be minus 6, minus 4. When you do minus 6 with minus 4, you get minus 10. And when you multiply minus 6 with minus 4, you get 24. As the common numbers, as when you multiply minus with minus, you get plus. Therefore, now you can write x squared minus 6x minus 4x plus 24. You can take common, x as common, and you will be left with x minus 6, and you can take minus 4 as common, and you will be left with x minus 6. Since x minus 6 is the common, we will write x minus 6, and the remainder is x minus 4, and hence you have solved your question. Moving on to question 7, we have x squared minus 23x plus 24. Now we need two numbers such that when we add or subtract them, we get minus 23, and when we multiply them, we get 42. Now such two numbers can be minus 21 and minus 2, because minus 21 minus 2 is equals to minus 23, and when you multiply minus 21 with minus 2, you get plus 42. So you can now write x squared, and instead of writing minus 23x, you can write minus 21x minus 2x plus 42. In the first one, you can take x as common, and you will be left with x minus 21. And in the second one, you can take minus 2 as common, you will be left with x minus 21. Since x minus 21 and x minus 21 is the common, you can take x minus 21, and the remainder would be x minus 2. And hence this is your answer. Moving on to question 8, over here we have x squared minus 17x plus 16. So the two numbers which when we add or subtract would be equal to minus 17 are minus 16x and minus 1x. And when we multiply minus 16 with minus 1, we would get the answer as plus 16. Hence, instead of writing minus 17x, you will be writing x squared minus 16x minus x plus 16. You will be taking x as common in the first one. You will be left with x minus 16, and you will be taking minus 1 as the common over here, and you will be left with x minus 16. Since x minus 16 is the common, you will write x minus 16, and the remainder would be x minus 1, and hence this is your answer. Moving on to the 9th question, over here we have x squared minus 21x plus 90. So the two numbers which we can replace 21x with are x squared minus 15x minus 6x plus 90. Because minus 15x minus 6x is equals to minus 21, and minus 15 multiplied by minus 6 is equals to 90. So in the first one, you will take x as common, and you will be left with x minus 15. And in the second one, you will take minus 6 as common, and you will be left with x minus 15. Because 90 divided by 16 is equals to 15. Now since x minus 15 is your common, you will write x minus 15, and the next number would be x minus 6, and hence you have factorized, and this is your answer. Moving on to the last question of our video, the question over here that we have is x squared plus 15x plus 56. Now you can replace 15x with x squared plus 8x plus 7x, because 7 plus 8 is equals to 15. Your first condition is met, and 7 multiplied by 8 is equals to 56. Your second condition is met. Therefore, plus 56. We will take x as common. You will be left with x plus 8. And the second equation, we take 7 as common, and you will be left with x plus 8. Since x plus 8 is your common, you will write x plus 8 and x plus 7. And hence, you have factorized, and this is your answer.